Hi, welcome to the Shiko Math Lab Mathematical Statistic Problem Solving session. So today we're going to solve a very interesting problem about the sample variance. So let's take a look. So we said let the sample variance S squared be the sample variance of a random sample from the normal population with mu and sigma square. So we want to find the three very common items frequently, deal with the sample variance. So first, I want to find the expected value of the sample variance. I want to find the variance of the sample variance, and then I want to show the sample variance is a consistent estimator for the sigma squares here. Okay, let's go ahead, go to our whiteboard and let us start to work on this problem. Okay, so here we go. So we know so let's first list a few facts we're going to have here. So in here we know if x1, x2, to xn is from the normal distribution with mu and the sigma square. So we know the sample variance is this is how do we define the sample variance as squares, right? So this is the summation I from 1 to n x bar xi minus x bar the square n minus 1. Okay, so we also know, so in here in order to solve this problem, we are using this known factors here. If the S square is a sample variance from the sample is from the normal distributions here. So we know this one here is n minus 1 to the S square over the sigma square. This random variable, this will have a chi-square n minus 1 degrees freedom. All right, so this is the fact we're going to use here. And in fact, the proof of this one is not too bad here. We talk about it in our other problem solving section. So in here, we will use this is our fact. Okay, so the first thing here, I'm going to find the expected value of S squared, right? So in order to find the expected value, so I know the whole distance here, n minus 1 S square over sigma square. This is a chi-square, right? So this is a chi-square distribution with degrees freedom n minus 1. So I know from the chi-square characteristics, so the expected value or the mean of the chi-square is what? Is n minus 1. Correct? All right. So now you can take the constants out. So it's n minus 1 sigma square times the the S square is equal to n minus 1. And then this one will give you the S square is equal to what is n minus 1 times the sigma square n minus 1. And boom, these two cancel. And what here? So sigma square. So in fact, this gives us one very good properties here, right? So what is here? So we said S square is an unbiased estimator of sigma square, right? So that's what we said is because the expected value equal to the parameter. So we say it's unbiased estimator. Okay, now the next things here, we want to find is the variance of the S squares, right? All right. So now in order to do this, let's take a look at variance of this random variable n minus 1. All right, the square and the sigma squares, right? Okay, so now this one's here, so because this is a chi-square again. So I know what is the variance of the chi-square will be 2 times the degrees of freedom, right? So it's 2 times n minus 1 here. Okay, so now this one's here, this is the constant. So I can do what? I can take the constant out. So this will be the n minus 1 square. So this is the sigma to the what? The force, right? So this will give me the variance s squares here is equal to the 2 to n minus 1. Right? So from here to here, I'm using what? I'm using the chi-square characteristics, right? So I know the variance of chi-square is 2 times the degrees of freedom, so that's why I got a 2 and minus 1. So now finally I can say this is a variance of the s square. It will going to be the 2 to n minus 1 times what? This is n minus 1 to the square sigma force. And then boom, boom, here I can cancel 1. So what is the answers here? So it's 2 the sigma force and minus 1. Okay, so this is the variance. So this is the variance of my sample variances here, right? So, okay, so it's variance of the s square. Okay, so now the number 3 is here. We want to show the s square. So this is the number 1 part, the first part. This is the second part. Then the third part, I want to show the s square. This estimator is a consistent. Okay, so I want to show this is a consistent estimator, right? So I want to say this is a consistent estimator. In order to show this, I need to use a theory from the consistency here. So we know the theories tell us, right? So if the, if t, so if I have any estimators here, let's say let's use the Tn is an estimator for the some parameter theta, let's see here. So in order to be consistent, so we say the first thing is here, the bias. So bias of this estimator going to approach to 0, all right? And the variance of this estimator going to approach to 0, then we will say the Tn is a consistent estimator, right? So that is a consistent estimator. Okay, so now I'm going to use, this is the theory about the how do I prove estimator is consistent. So that's the theory I'm going to use. Okay, so now let's take a look from the part 1. From the part 1, I just proved s square is equal to the sigma square. So I know the s square is unbiased estimator, right? So this is unbiased estimator. So do I have a bias here? Because it's unbiased, so the bias of the s square is equal to 0 because it's unbiased. So I know bias here. All right. So then the next thing is here, next condition, the theory tells us it's variance going to approach to 0. I just show here, we just from the part 2, I just find that the variance square is equal to the 2 sigma force n minus 1, right? So when the limit n approach to infinity, the variance of the s square is equal to the limit n approach to infinity n minus 1 2 sigma force. So what is this one's here? This one is 0. right? So I satisfied both conditions, right? So I satisfied the bias going to approach to zero and the variance approach to zero here. So that is why I can conclude the S square. Okay, so then I can conclude S square is what? S square, the sample variance is a consistent. So it's a consistent estimator for what? For the sigma square. Okay. So this is one very, very popular type of the mathematical statistic type of problem related to the sample variances here. All right. So the good characteristic about the sample variance is unbiased estimator for the population variance sigma square. Also, S square is a consistent estimator for the sigma square when you sample from the normal distributions, right? With mu and sigma slab. All right, that's it, and I hope you enjoyed this problem solving session and find that this is helpful. Okay, and so please, feel free to subscribe the channel if you find that this is helpful. We have more problem solving sections, so will come, continuously. All right, that's it. Nice to talk to you and looking forward to talk to you in the next time and try to solve another fun problems here. All right, bye-bye. Have a good day. See you. All right, bye.